Welcome to the next video of this series. The last video where we left off was vulnerability data analysis and prioritization. Now we're just going to do a bit of incident response management techniques. So we're going to take a bit into a few exercises and tasks with doing these, and also go over what this actually means. So reviewing incident response playbooks, I mentioned playbooks a few videos ago. It requires a dedicated process of planning, detection, and analysis, right? So like containment, eradication, recovery, post-incident activity, right? So NIST, right? We have to make sure we mention NIST. So through the SB 800 through 60-61, it provides the computer security incident handling guide, and CISA has operationalized the NIST guidance into the cybersecurity incident or vulnerability response playbooks, right? So these publications may serve as the backbone of incident response or creating enterprise-specific playbooks, right? So Microsoft actually provides vendor-specific incident response playbooks that may be directly implemented or included as part of a private enterprise incident response. So we're going to do a bit of NIST incident handling. So actually, let's open it up. Let's open up Microsoft Edge, and then we're going to take a look here. I'm not going to read too much, I promise. Okay, got to make sure it's secure. Let's see. Was that long enough? I'm not sure if it was long enough. Should be loading in just a moment. There it is. All right, perfect. So let's actually head down to page 30. Right, so handling an incident, right? So this section of the publication, right, it provides guidance on how to implement the incident response lifecycle part of what I was just mentioning. So the guidance provides definitions and methodology guidance, right? But it can't be necessarily directly implemented during an incident, right? So now to implement the CISA Cybersecurity Incident and Vulnerability Response Playbook, you could do a few things. Actually, I'm going to, let's see, so I don't have to type everything over. Let me open this tab and then there. All right, and then actually I'm going to page 5. Then I have an incident response playbook for CISA, right? So when you discover the playbook based on the NIST guidance, right, it provides actionable implementation to include, right, as far as like some sort of checklist that you can have, as far as methodological way of doing things, right, as far as incident response. So we can actually take a look at the Microsoft incident response, right? So here's their incident response playbook, and actually let's take a look at where is it? There it is. All right, so we see there's a workflow, right, that shows us the logical flow that we should follow to perform this investigation. This is a vendor-specific tactical level guidance, right, for incident response. So, so those are the tools you can use for different playbooks, right, and different implementations, but they pretty much all like very similar general guidelines. And some guidelines, as far as incident response playbooks, they vary based off the type of attack, type of enterprise that you're in, the type of industry, as far as things that you want to follow. But we're going to move forward to our next exercise, where we'll be using Splunk to monitor for port scanning. So critical phase of the incident response lifecycle, right, is detection and analysis. You want to detect it as soon as possible, analyze what happened as thoroughly as possible so we can understand what happened, mitigate any additional risk, right? So we can remediate. So this a key indicator in the detection process is logs, which is what we use Splunk for, right? So we're going to do a few things with Splunk on this one, sir. So let's actually make sure I'm on the correct. Yeah, I am. All right. Let's see, command should load something for me. There it is. I was wondering what's going to load here. All right, perfect. Let's see. That is not recognized as a command. Oh, that's fine. All right, so I'll just type it out here. Bear with me a moment. All right, so I got my command in here that we needed. Let's see what happens here. Is it working? All right, so alternately, the text may be highlighted and transferred to the server through the menu or the web clipboard. But this is the install command that should be installing this Splunk Enterprise from its downloaded location, right? And it will pretty much, I'm pre-entering the username and password into the install application. And so it can be pre-filled during the installation, right? So when I actually have the app loaded after it installs, then I'll already have the user and password already there. But it looks like it doesn't feel like working today. There it is, my guy. All right, perfect. Okay, there we go. And of course, we naturally want to, let's see, should we customize our options? No, we don't have to. All right, username. Install. May take a few moments. All right, so we finally have it finally fully installed, and we're going to have, it should populate for me automatically. Yeah, because I told it to populate for me. Let's see. Here. There it is. That's not it. Okay. All right, let's fix this. All right, perfect. So we finally got everything installed and loaded up here, and I've logged it to the admin portion of the account. So now we can head to our settings. Then we can go to the forwarding and receiving section here. Then at new, we're going to do port 9997. I'm going to save that. Okay, there, let's head back to the home page. We're going to do, let's see, searching. Skip, don't need a tour. Actually, let's see. And I'm going to start the defender. Let's see. Hold on. Now roles. The role port. We're going to add the port that we just placed in. I think we want to do one more too. Next, let me. So TCP, of course, we want to allow the connection. So now it's configured to listen to port 9997. So it's going to be the default response management port that will enable remote management. And let's see. Finish. Then let's go back to the command prompt. Then let's enter in the last thing we did. I'll just have to do it again. Let's start typing here. All right, perfect. So I have the command ready to go. Let's go ahead and execute. Okay, so it should get started. It's going to take a while, but that's fine. All right, so I'm using a different server instead, which is okay. That's what I should have done to begin with. Let's take a look at a few customized options. So actually, it should be just get through here. And then here's the name you want. This one. No. Okay. Okay, use a different one. That's fine. What did I have at first? There it is. I'll just do that. Fine. I'll check all these boxes here. Actually, see. Okay, now I can do. Yep, yep. Perfect. Now the install. Now it's going to be installed and configured on this server, DMO1. Shouldn't take long. All right, so finally it's finished. So So we're good here. We're just going to click finish and minimize that task now. So now we're just going to install and configure the TA WinFW. Now, Windows by default, it does not log successful connections. Additionally, the firewall logs are not normally parsed and ready for interpretation by a log collector, unfortunately. So we're going to install the TA add-on and configure it to forward log firewall logs to Splunk. And let's see, let's open up Edge to get that started. Then let's go here. Let's see, code. Sorry, good. All right, perfect. So let's actually let me go back. Copy here. Then let's go to let's see. I'll have to put it manually. Okay, perfect. There we go. I'll just paste that here. All right, perfect. So let's see. Let me open this up. Then let's take a look. Should be another file. Oh, there it is. That's what I was looking for. Then inputs, copy. Now we're gonna pretty much want us to do the same thing, but I'm not. Actually, you know what? Let's here actually just delete this. All right, perfect. So now let's take a look at the look at that notepad. Okay. Then we're gonna this here. Additional things here as far as the inputs for the configuration. Now we're just going to save it. All right. Let's see. All right, so now I'm looking for the Splunk forwarder. And restart. Okay. All right, so while that's doing that, I'll be doing this. All right, perfect. So now let's see if we want to log successful connections, most definitely. And we also want to, never mind. Okay. Let's see. All right, so we're gonna also do the same thing for the local computer as far as logging successful connections. All right, perfect. So we got that taken care of. And now we're going to move forward with identifying port scanning with Splunk. So now with the Splunk Enterprise and the Splunk Forwarder setup complete, now we can do some testing. So in this task, we're going to conduct an nmap scan of this server that we're currently on and configure Splunk Enterprise to identify the scanning IP address. So we'll then conduct an nmap scan from this server here. Actually need to activate it and the current server that we're on to ensure that the Splunk Enterprise can identify a new scan from a new IP address. So just going to connect here. Let's see, actually, let me do both of these here. All right, so now that I have Kali up and running, let's open up the emulator here. We're gonna do some, get our hands dirty with some scanning. All right, so let's do this here. All right, now we started the nmap. Now it's gonna, may take a few minutes to complete, but while we're doing that, that's fine. Let's reconnect back to this one. Let's, oh, we already have Edge open. All right, so, and as we're going to do a search here, so we're gonna do source type. Okay. All right, perfect. So now Splunk is, don't know how to spell apparently. There's quite a few words there. Now Splunk is receiving these logs, right, from the Splunk forwarder for this particular service. So the source type identified by the inputs configuration file identified these forwarded logs as coming from the source type WinFW, right? So I'm going to scroll to the bottom of the fields column here, and I'm going to do extract new fields. Now the TA application, it parses the log files, log fields as they are forwarded, but the Splunk does not label the parsed log field automatically, so it'll be done manually, hence me doing what I'm doing now. So let's see, the top row, the raw output, let's take a look there. Okay, so this step, it just selects the first forwarded packet in its raw format. So let's hit next here. Oh. Wrong next. All right, so now we can see a few things, the XYZ delimiters, right? So as we can see, pretty much the explanation here is just going to extract fields using this, such as comma spaces for delimited data, separated values, right? And then, let's see. Okay. Oh, there it is. All right, perfect. So now we're in the rename field section, and I'm just going to do the space tab here. And just going to, let's see, field 5. Let's rename it to SRC, which is source. IP should not be compromised. There it is. Rename. And then field 6, we want it named for DST. Well, there it is. Rename. And now for field 7, we want DST port. Got source, destination, IP, destination port. It's kind of similar to what we did a few videos ago. So now we can hit next. Now we have those renamed. And then for the report, we want it for scanning. It's easy to identify. So now we can finish. And then success. We've extracted additional fields from our data, which is the source type. And now we can actually head back to the home screen. And then search and reporting. So we're going to do the source type again. This time I'm going to actually spell it correctly. So, and I didn't. Okay. There we go. All right. See, we're loading a few events. So let me take a look at all these fields here. So I just want to make sure I check off a few. The ones I particularly named, these, this one. I did port IP. I did another one. Source IP, there we go. Perfect. All right, so let's close this one. Now it's gonna show mine as far as the selected fields that I have. So now I'm just gonna do a new search. All right, so in the search, just gonna put just a few things here. Let's see. All right, so I finally have the search input, and let's take a look here while it parses. Now, in this case, the criteria which has been established to search for indications of a port scan, right, on this particular server, which is greater than 5 port connections completed, and that the scan source was not the actual IP that I have here, 0.2, but its criteria is valid for the lab condition that I have, because if implemented at an enterprise level, it will likely be modified to include the number of packets received and connections made over a shorter period of time. Now, if we observe in a search input that let's say 0.5 was identified as meeting the search criteria for conducting a full TCP connect scan, then it would have resulted as such. But now we're going to conduct an Nmap scan from another server and determine if the rule set created above in here, can identify a new scan from a new IP address. So let's head on over there. It should not be asking me for a password. All right, so let's take a look. So let's do the scan here. Host discovery disable. All addresses will be marked up and scan times will be slower. That's fine. All of the scanning. Now, it may take a few minutes to complete. Once that completes, then we can move forward with the next step here. And you know what? While it's scanning, I'll still pivot over to our other server here. I shouldn't really mess with anything. Let's see. I'm going to use this function here. Just going to put that in. Configure Windows. Actually, you know what? Let me just do this again instead. There it is. So it shows more than one. Perfect. So as we can see, again, as I just mentioned, more than one. So the 0.4 now shows up in the search results as meeting the defined criteria for port scan. So everything is on the up and up, and that'll be the end of this video. Well, I'm sorry, we actually have another exercise. It's not the end of the video. So what we're going to do now is create a forensic image for investigation. So then this is part of the incident response management, right? And it must include a forensic investigation. In order to conduct an electronic investigation and discovery, a forensic image of the source data must be made, and the copy data may need to be mounted so it could be examined. So what we're going to do is prepare a data source partition for forensic imaging, right? So let's swivel over to this particular server. So we can actually go here. And there it is for this management. And for this, now let's see, we're going to shrink this value here. We're going to shrink it down to about 3,000 megabytes. Shrink. Okay, perfect. Now for this 0, let's see. Actually, should be in the, yeah, there it is. So let me create a new value. Actually, let me see. Let's actually open this. Need to label it properly. All right, perfect. So I got it relabeled into data source versus just having a generic name. And the value that we just created will serve as the data source for the forensic image. So now we're going to create the value that will host the forensic image. So let's see, for this 0, let's click here. I'm going to shrink that value also just a bit. Shrink. All right, perfect. So now this value will be the location for the forensic image, and it's intentionally made larger than the actual data source value to ensure all data from the data source can be forensically copied to this value. So let's see, for the unallocated, do a new simple volume. Then we're going to name it image storage. Okay. Make sure, yeah, it's going to be okay. All right, then that's fine. Now, let's see, let's take a look at the file explorer. Go to see, here we go. We're just going to copy this folder. All right, perfect. And then we're going to go ahead over to D. We're going to paste. All right, shouldn't take long to complete. Just only 12,596 items. All right, so finally finish pasting. So now the files that would not copy, that's not necessarily important for this exercise, but in this task, we created a volume of data that will be forensically imaged for the next task. So now we're going to install the OS forensics application and create a new case, which is a commercial product for forensic investigation. So the tool conducts of all aspects of the investigation recovering from data to creating exports. So we have the file explorer open. So let's take a look at the downloads, and then let's open this up here. Okay, definitely speaking English today. Let's open this up. Then that's fine. Then we can hit install. Shouldn't take long at all. All right, so we have it finished. So we're just going to hit finish here. As far as the install, and then there it is. Continue the trial version. You can manage case. Then new case. This case name is going to be. This is a drop down. What's going on? Doesn't let me type here. Huh. That's strange. All right, let's go ahead and see what we can do to fix that. All right, so we're going to name it data source investigation. Okay, all right, perfect. And then we're going to select the local, and then browse where we want to put it. Let's take a look at this. Then image storage. There we go. Make a folder. We're gonna name the folder images. Perfect. Everything else looks pretty good. Now we can see the case that we've created there. So now we're going to move forward with conducting a forensic image and mount the image on a partition for forensic investigation. So now we have a data source identified and an image storage partition. So the OS forensic tools can be used to create a mount an image. So we're going to use OS forensics to create an image and then mount the read-only image for investigation. So let's see, create an image and then let's see, add. And let's see what we got here. Partition. I'm going to set up the partition for SD drive for what we had earlier. And then let's see. Now let's name it pretty similar to what we had before. All right, so now for the image settings, we're going to select the hash 256 that we want, and MD5 for the secondary. Then we could start disk imaging. Right. Now, as the forensic image is being created, right, we can observe the primary and the secondary hashes. because these are created during the forensic copy to ensure the integrity of the data itself, right? So while this is doing this, I'll actually just hit start here so we can move forward with a few other things. So now where is out here? Actually, you know what? Let me just type it. So perfect. All right, let's do a new one, new mount, like I mentioned. And then, let's see. Oh, where's the image file? There it is. Okay. I want that open. Okay. And then now, I believe that's everything. Then actually, we're just going to exit. And then we could do File Explorer. And let's move the F users. Let's see. I would. All right, so if for some reason it's showing a different this name than what I was expecting, but this is the mount of the forensic image that was created. All right, and let's see. Here. But yeah, so as a mounted forensic copy, the contents of the drive partition are not modifiable typically, but we can see that there is no option to create a new folder, right? So, well, this should not be. Let's see, it should be, okay. Well, typically, I'm not sure what's going on with this particular lab at the moment, but typically it doesn't, would not allow you to create a new folder because of the mounted forensic copy, right? And that the contents of the drive just not being able to be modifiable. But nonetheless, this is the end of the video for incident response management techniques. So we did a few things. We reviewed incident response playbooks. We used Splunk to monitor for port scanning and some bit of port forwarding, and also created a forensic image for investigation as well. And on the next video, we'll be looking at incident response communication and reporting. I'll see you in that video.